Hello everyone and welcome back. In this video, I show you some Kubernetes by example. We dive into the so-called example construction kit. You find the link in the description on my GitHub. And I explain you a little bit about Kubernetes, how you can build your own Kubernetes platform very easily. And we might also dive into a little bit of service meshes later. So without further ado, let's dive in. Okay, so this is my so-called example construction kit. Before you begin, there are some prerequisites that need to be fulfilled. There is a short README, and then there is, it points to another folder where you can find specific instructions on how you can get a simple Kubernetes running either in Linux or in Docker. So on my Mac, I'm using Docker Desktop, which you can then just download. What you need to do is you need to take a look at the resources. You should have, at least on my machine, 6 GB of RAM. The standard is 2 GB, which is not enough. So 6 is quite okay. And to activate Kubernetes inside Docker Desktop, you need to tick this box. And then this takes a little time. And then afterwards, you will have a Kubernetes system up and running. For Linux, it's a little bit different. You need to install micro Kubernetes. There is a description here. You can look it up. If this is running, what you also need to do is you need to have an entry into etc hosts. So basically this guy here. And so that if you do ping Kubernetes, that this will answer with your local machine. What you also need to do is for HTTPS communication, there is a root certificate you need to import into your environment of your operating system. For me, it's macOS. You will find this here in root config root pam. Otherwise, you will get certificate warnings. And you need to have kubectl, which you will have if Docker Desktop is installed, and you also need to have the command line version of Helm. And if you have all of this fulfilled, you're pretty good to go. So what you need to do is that if we are in the terminal, we go to Helm, templates, infra, and we then just say stack init. And this will do a lot of stuff, which I explain in a minute. It will now ask you about the name of your server. So if you're running on a local machine and you created the Kubernetes and etc host, I explain further, you can just hit enter and it will use Kubernetes as a machine name. That's very important because with this name, we will access it from the outside. And then everything should already be up and running. On Docker Desktop, there is an additional step that is hinted in the installation guide. You have to go to 7 add-ons, Nginx controller, and then you have to say stack init here. This will currently fail because I already installed it, and then it will also drag in the Nginx controller, which is important for having access from the outside via HTTP. So this might take a while because it needs to download stuff from the internet, but eventually you can open up your browser and you just go to https Kubernetes welcome, and you should hit this nice welcome page. This has a lot of links. Some of them are currently not working. What should be working at first is the Kubernetes dashboard. Now, for every link you click, you will be greeted with a login screen. This is currently the super secret user password admin, but you can change it if you want. It will ask you about some additional login. You can just skip it here, and then you will be prompted with the so-called Kubernetes dashboard. In the Kubernetes dashboard, you already see so-called namespaces, which contain applications or infrastructure stuff. And currently there's not a lot going on here. Only in Kube system we find the parts of the Kubernetes system. And in Ingress Nginx, there should be the Ingress controller on Docker desktop, but that's it. Oh, and we have in monitoring, we have our Kubernetes dashboard also installed. So we should take a very brief look into what's going on here. So if you do stack init in the info folder, there are additional subfolders that will be executed. This is basically a script that goes all over the folders and calls the specific stack scripts here. So the first one is a so-called namespace folder, which just creates a bunch of namespaces that need to hold the applications and system-specific things later on. We have a secret syncer, which helps us to synchronize secrets. So for example, the authentication you saw is a secret. And for Kubernetes, it can only hold a secret per namespace, and you have to copy this manually if you need the same secret multiple times. And this secret syncer will help us here. We have the authentication part, which generates the secret for the authentication, the admin. We have the certificate, which creates a HTTPS certificate so that we can connect via the browser. So what you see here, that we have secured connection here. Registry is currently not used here. We have the dashboard and we have monitoring and add-ons, which we can take a look on later, and also the welcome board, which you see here, which is basically an HTTP page. Okay, not a lot going on here. We should now bring up some applications. For this, we go into Helm, templates, example, and now they have two options. You can either use a bunch of Quarkus applications or Spring. It's the same applications, just two different flavors. I use Quarkus here because it's more memory efficient. And this time it's not stack init, it's stack up. And it will bring now up all the applications needed. It's a bunch of applications. We can take a look again at the dashboard. And now we will see that in these namespaces, example namespaces, applications will start. This takes a minute. We have a fire facade here, and then we have two different tenants because we are using here multi-tenancy separated by namespaces just for the purpose of this demo. It will bring up the applications for our tenant 0 and for our tenant 5. Well, there might be some errors because sometimes the database is not answering fast enough, but eventually the application will work. A nice part, of course, of the Kubernetes dashboard is eventually we will see the memory usage here. This takes the time. And of course, with the Kubernetes dashboard, we can anytime take a look into the logs for every application. So this is our person service. This is our callee service, for example. The downside, however, is that we need to take a look into each application log individually. I will show you a better option in a minute, but now I think everything should be up and running. No, we still got some errors. Okay, this takes a while. But eventually the system should come up. We can already take a look here in our person service, which is basically communicating to the database, and it can also contact the so-called callee service and do a REST call. So basically this Heisenberg here is delivered by our callee service here, this guy, which is basically an application without any database, while this person service has a database and can do REST calls. Let's take a look if our application, now our whole stack is up. So we basically have these two applications deployed redundantly into different tenants. And in front of this, we have this fire facade, which will simply delegate to one tenant or another. So what we can now do is I want to retrieve a patient. This will go to the person service and then eventually call the callee service. And this will return the patient in the so-called FHIR standard. Okay. So that's this. Now, what else can we do? So applications are running. What would be nice to have some additional monitoring here. So you see these two icons here, Jaeger and Loki. This can help us with additional monitoring besides the Kubernetes dashboard. So what we need to do here is we go again into Helm templates infra. Then we go into monitoring, and this helps us to plug in some additional things here. So we say xstack init, and this will bring up Jaeger for Jaeger tracing, and this will also bring up Loki for monitoring. Could take a while. So Jaeger should now already be accessible. There is not a lot of stuff going on here. What we now need to do is to create some requests. So I basically do request to patient and another one also to practitioner. And then we should again take a look into Jaeger here. And we now see the services coming up. So we can now say, please show me the so-called traces of the fire facade. And will show me the traces. This is separated into so-called spans, which help us to take a closer look into the application. So what we see here is that our fire facade application has several more spans that give us insight about that the fire facade calls the person service, which calls the callee service, and then there's a second GET request, which calls the person service directly. And these bands measure how much time it takes. So this helps us to take a closer look into the application for tracing. In this setup, this just works right away. Every request will be sampled, as they call it, and you will see it right away. So you will see every request. This is not the normal condition in big production systems. Normally, not every request gets sampled, but usually only every 10th request or every 100th request. Okay, then we have another guy, which is called Loki here. This helps us to get an aggregated view concerning our logs. So what we need to do here is to say explore. Then we say Loki. This is basically based on the Grafana stack. And now we have some kind like expression language here. And now I can, for example, say namespace example tenant 0. And this will now show me all the logs of example tenant 0 of all the applications. Remember, we have an example, we have a person service and a callee service and other things going on here, and it will show me in an aggregated way all the log files. I can also do filtering. So for example, if I want to say I only want to see the warnings, now I only see the warnings. Or if I want to say critical, obviously we had a critical violation here. We can take this off and then we could see all the logs again. We can also say, please show me the logs of this namespace. This will also work. And we can narrow this down to container. And then we say, just give me the logs of person service. And this should also work. Okay, there is no logs currently going on here. So what we also can do is live logging. So this basically gives us a live view concerning our logs. So now every time we will do a request, we should see this here. can try this. So for example, I now do a request. The log should just continue here. Okay, that's it about Loki. Before proceeding any further, let's take a brief look into our configuration here. So in our examples, and a brief look about what Kubernetes does and how things are described. So now with our applications being up, and we used the stack up script, you can see that, for example, in the Fire Facade application, we have this so-called YAML files. How does this work? We use a technique which is called Helm 3 to be exact, to be specific. And this works that we have this overall so-called Helm chart description, which contains the name of the application and also some versions. And then we have this templates folder, which contains part of the system that describe how this thing gets deployed in Kubernetes. What are the important parts here? So one of the most important is the so-called ingress. This defines how we can get from the outside into the application. We have a so-called service, which we always need if we want to connect from the outside into the application. We have a deployment, which does not describe, like the other parts, how to access the application, but the actual deployment of the application. And then we have other parts like config, which is basically configuration stuff, and also secrets, which basically holds, as you see, secrets. So these are basically passwords that are encrypted. You see here, these are base 64 encrypted, but encrypted is not the right word. They're just somehow obfuscated because you can easily decrypt them. In a real Kubernetes system, our little Docker desktop has some limitations, of course. These things can be encrypted with some kind of AES-256 encryption. In a standard minimal Kubernetes environment, it's just base 64. Okay. So that are the most important parts. So what else can we do? So as you see here, we have some more things to explore. What I need to do first is to bring down my application stack. You will see in a minute why. And then it might be fun to explore some additional things like a so-called service mesh. So to bring up our service mesh, we go into 7 add-ons. We have different options. We can either have Istio or Linkerd. So I'm opting now for Istio. I go to Istio and I again say here stack init, which will again do a lot of stuff. It will install some additional Helm charts. It will also bring up a so-called operator, which helps us to install the service mesh. So what we are now having is this namespace is the operator, which should bring up the operator, and it will eventually install stuff into Istio's system. So you already see we have now our so-called Istio daemon, and we have Kiali, which is the dashboard. And this went pretty fast. So now additionally, we have this so-called Istio dashboard, this guy here, which gives us insight into our applications. But as you see, we don't have applications installed. Why don't we have applications installed? Because before you bring in the service mesh, your applications needs to be stopped because the service mesh adds an additional proxy. So now the applications being stopped, we bring up our applications again, and this will now start all the applications and inject a so-called sidecar proxy. This will take a little longer. And eventually we should see our applications here. select all namespaces. Here. So now our applications are getting up. We jump back into the Istio dashboard. And what we will see now is, if we take a look into the logs, we now have our application and we have the so-called Istio proxy. So this is a sidecar, and the sidecar enriches this thing with additional functionality like monitoring and HTTPS communication and other stuff. And this is why we have two containers in the same so-called pod. We have our original application and our proxy. Istio can do a lot of stuff, but what is not visible here, this proxy takes up a huge amount of memory. So our Quarkus application usually is about 20 megabytes of RAM, and the proxy consumes about 50 megabytes of additional RAM, which is, of course, in contrast to the 20 megabytes a lot. But it can do a lot of nifty and nice stuff. So let's take a look. Our applications seem to be running. Okay. And now we will put some load on the systems. For this, there is already in doc JMeter, you have this fire facade patient load thingy. You need JMeter for this because to see something happening here, it's not enough to just do small and just a couple of requests. We need to have some load here. So we start our load. And it's working. At least it looks like it's working. Okay, now back to the Istio dashboard. And we have this extra section, which is called graph. This takes a while to get up. And this will show you now all the parts of your system and how they connect and intertwine. So I tick some extra boxes, which are security and traffic animation here. Let's untick the traffic animation for a second. And it's a little small, but you see here now this little log, which indicates that automatically via the service mesh, our application is secured. So communication between our applications also, if we want this to our database, is secured with TLS. For the database, it's currently shut off, but for the other applications, this is on. And then we can also tick this very nice graph here, which shows us the communication. So we see we come from the outside against the fire facade, and this will delegate either to this tenant or this tenant, and this will then delegate to the other parts of the system. Okay, what else have we got? So we can then, if we want to, drill down further into the applications by clicking here and clicking here. And then we get some additional metrics. We get inbound and outbound metrics, which measure the throughput of our applications. We have JVM metrics, which of course for a Quarkus application, only some parts can be visible because our Quarkus application are not based on JVM, it's native images. And we also have this section, which is called tracing. And the tracing is basically an example how this is displayed again in Jaeger, which we installed earlier. But the thing is, you see now we have more spans, so things change because now with Istio brought in, we get additional spans here. So what you see, now also the proxy becomes part of our span infrastructure. So you see this, we have our application, and then you have this .example additionally, and these are the things brought in by Istio, which now also measure what the sidecar consumes. It's important to stress, because this is sometimes a misunderstanding, you don't need a service mesh to use Jaeger. I showed you this at the beginning, but you can bring in a service mesh and it will enrich the graphs with additional information at this point. Okay, So back to our graph, everything is nice and shiny. I just hide some things here. So, but of course, not always everything is green. What we can also do is to bring in some kind of interruption. So for this, I go to example tenant 0. I go to person service, Postgres, and I will shut down my database, which is usually not a good idea. We'll uninstall the database, and we will eventually see that parts of the system will fail. Okay, it takes a while. Now you see things are getting red here towards our tenant 0. Yeah, and this is very nice because now our service mesh, our Kiali dashboards help us to find out where we have problems in our system. I will bring up the database again, and this will kick in the auto-healing functionality that our container orchestrator Kubernetes has. So now with the Postgres bring up again, the system will heal over time. It takes a while, but eventually everything should get back to green again. Okay, takes a little bit longer than expected. Let's take a look. Yeah, system is taking quite a while. Shut down this. Okay, now it's getting back to normal. The graph jumps around a little bit, but that's normal. And now we see we have still this guy here. This will vanish in a moment. And now we see that our connections are still green again. Okay, that will do it for this video. Thank you very much for your time and attention. And I hope to see you in the next video. Bye.